Rudder? 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 Could you take it outside? Thanks. Okay, it's 10:30. It means it's time for the Collada buff. Woo! So we have Remy and Mark here from the Collada working group. Who's going to give us an update on the Collada specification. Now, I'm sure most people here are aware we actually have two 3D formats, standards at Khronos, Collada and GLTF. GLTF is the BOF following this one. But the reason we have two formats is the use cases for both are very different. And I was just going to introduce one slide here, comparing and contrasting the use cases, and then Mark and Remy will dive in and give you an update on the latest activities with Collada. So Collada is for asset interchange, and it's highly sophisticated, where you can keep all of your data. You can use Collada as an interchange format during the authoring process. It's an ISO specification, so you can use it for long-term archival. But really, most people in the industry, I think, use Collada for taking their assets in and out of their favorite tools to create the pipeline of tools that they want to use that fits their own use case. And we have an increasing number of authoring tools that import and export Collada. And that's a very different set of use cases to GLTF. GLTF is not an interchange format, it's a transmission format for taking data once you've created it and efficiently and simply as possible getting it down to runtime applications. GLTF came originally from needing to get data into WebGL, but now with WebGL 2, and we're here in the next BOF, much more widespread usage of GLTF is appearing very quickly. So GLTF is compact, Collada is exact, but the two are linked because we have translators from Collada to GLTF, which again can be a vital part of the tools flow. If you've created your assets, you actually want to get it out of the tools flow and use GLTF to transmit it to your runtime. We have now some direct exports for GLTF appearing from tools like Blender. So Collada and GLTF, two different file formats for different use cases. So let's hear more about Collada.
Thank you, Neil. It's a pleasure to be here. It looks like we haven't been on stage in a long time like that. So I thought and it just happened that we work with some company now at Starbreeze, and we've been using Collada for quite a while now to do game production, and which is why we did a lot of improvement on the system to make sure it works fine. So I'm one of the at the origin of GLTF. I really wanted GLTF, and I'm very happy where we are now with GLTF. And the reason is, like, a lot of people try to use Collada to export directly in the runtime, and it doesn't work. It's not done for that. It's not designed for that. Collada is something you need an editor or a tool. You need a pretty sophisticated game engine, I mean, like Unity or Unreal, to grab all your assets and do something with it, put them together before you can actually use that and export them for the runtime binary. So I'm really happy that we now have this specification that help end users to choose the right format for what they want to do. So, some history. I mean, Collada is very stable right now. It's been stable for 11. No, I mean, what's that? 1.4.1 was in. I forgot when that was released. 2008 or something like that. Yeah. So. And since then, there's two branches of Collada. There's 1.4.1, which is the one most people use in the game industry, I would say, or every single tool have a Collada exporter. That's the 1.4.1. Then you have 1.5, which is the ISO path, which has a lot of IK. And ISO is, the 1.5 is, we don't talk about it too much here, but it's been used by different organisms, and they extended it and they embedded it into their own format, and it's really cool that they can do that because of the definitions of Collada and the fact that it's ISO. So two main users that I know of. One is called OpenRev, and it's actually a library used to define robots that are used to manufacture in the manufacture process or other robots. And so when you buy a robot, you can have the model with its IK of your robot that you can enter your simulation, your factory simulation. You can get that through the open web format. Another one that we work with at the beginning, that's actually how 1.5 was financed and developed. It's the automation email. Industry standard for automotive makers to dialogue with their providers, their third parties that needs to provide parts. A lot of car manufacturers buy a lot of pieces and put them together, and that's the language they use to communicate with, huge industry used mostly in Germany, where all the good cars are made, I understand. So, so this is Collada right now used a lot in the 1.5 flavor. In the 1.4.1 flavor, it's doing a lot of work in the more entertainment space and game space, and so it's still evolving, but it doesn't need a lot of evolution of the specification because we designed it. I mean, especially Mark designed it, so it's totally extensible, and with that, there's a mechanism to do that. And we actually use that mechanism lately for some new extensions, and which we're going to talk about it quickly. And Mark is going to re-explain the process on how to make extensions, publish them, and make them interchangeable, which is the goal. So we're going to focus on this thing called Open Collada, which is a Khronos open source project, which is the library we created a while ago at Intel, and it's owned by Khronos and open source. And it's just a community thing. It's not it's not like Khronos is working on it. It's just Starviz has been working on it. Other people have done commits to it, and that's the basis of a lot of things. It's used mostly for Collada Max and Collada Maya importer-exporter, so it's a fundamental library underneath. It's also used by Blender for their import-export, and it's also used by Collada to GLTF, which we'll probably talk about in the next presentation. So it's a fundamental library to import-export Collada that we rely on nowadays. And we do a lot of work on the Maya, Max and Maya exporter, as we're going to show now. What we did recently, and it's pretty interesting, we actually revived a motion builder exporter, which actually used a very old library called the Feeling Software library. That's the first one we did at Sony. And we did not change that. I mean, if somebody wants to do it, why not? But we just make sure it still works, and it still works, and it still builds and export Collada. And we use that in production. I explain why and how it's very useful. Of course, you can use Collada through the FBX library, which is covering all the Max and Maya. So you don't have to use the Open Collada, but if you want to use all the extensions, you should use the Open Collada exporter. There's Unity also. Something that we talk a lot about, how import export. So I've got some questions about that. So just to address those. So Unity imports Collada. It just uses Autodesk FBX library, which has Collada import. So you can import Collada in Unity since it always has been importing Collada. But Unity is not an exporter, but it has extensions. 2 of them are listed here. You can export from the editor, or you can also import Collada into Unity. So it's pretty cool. The connection. You have all the bits and pieces to connect the different parts together. That's kind of the things I've been worked on recently. So. In the import-export, so you can use the one that's provided with the tools, or you can, of course, if you do your own tools or your own runtime on it, or you want to use a library. So we talked about Open Collada. There's Collada DOM, which is still used by a few things, but it's honestly, nobody's working on it, so it's not something I would recommend to use. Async has been it's an open source, has nothing to do with us. I use that into some of the projects. It's really good at importing a bunch of different formats. You can use FBX, like I said. You can use, and there's always some new projects that are pretty cool. So I wanted to point that one out, done by a new. It's just I think it's a studio that's creating a new code, new modern code to do that. So there's always something new that's based on a spec that's created. So that's how standards live after 10 years. So. The motion builder exporter I just mentioned that we revived is pretty interesting. It's one of the things that's the basis of how you, why Collada is interesting. So imagine you're using two different tools. You have Maya and Motion Builder, and of course you're going to use that in production. So in Maya, you make your skeletons and you make your skins and you export. But now you need to animate that. So with Collada, it's interesting. You can use multiple skins for one skeleton, and you can have multiple animations for the skin and so forth. But you don't use the same tool. So how do you make that happen? So if you have only one path, if you have to put everything in one format, in one file, then it's a pain because you have to bring one tool to the other tool and then blend this in there and then re-export every time. And you have several export paths, and they have to be synchronized. The tools have to be the same version and so forth. So with Collada, what you do is not that. You actually export your skin and your skeleton with Maya. You actually import that once in Motion Builder, then you create all the animation you want, and then you have completely different working path in production. We can add more animations. And what you do is just import those two Collada things inside your engine and directly there. So you don't have to re-export and remesh everything together. It's the powerful use of XML, URL, and Collada definition that enables you to do that. So that's proven to be easy to put in place and very, very useful in production. All right, so I'm gonna let Mark continue with the presentation.
Thank you, Remy. Hi, everyone. At Starbreeze, we've used Collada for some internal engine development for game engine stuff, and we've wanted to have some quality assurance in our own pipelines. So we looked at the conformance test suite, which was published by Khronos many years ago, and we wanted to add those features to Open Collada, which is also operated by Khronos. So that's what we did. We took the important test options or test cases that were needed for our production pipeline, and we added them as not only as a library within Open Collada, but also as a little application. So you can run the application and verify all of your own DAE documents. It's also used to do the 1.4 spec and the 1.5 spec. So it's useful for all the different markets that Collada supports. And also it does the new PhysX extensions, which I'll talk about in the next slide. And so we run the unit tests for Open Collada itself as part of our continuous build and integration of Open Collada, which I'll talk about in a couple of slides. So the main things it does that we found useful was to verify the URIs that reference in between the documents. So it's what you would think of as an external referencing mechanism. It's all URI based. So if you have a whole folder of documents and they all refer to each other to make your whole asset, the tool will go and check that all your URIs resolve to files. And if there are any URI fragments or hashtags, they'll resolve to elements within those files. So that's a good coherency check to know that you don't have any broken links between your data. We also do unique ID checks, which are constraints on XML schema level constraints on the IDs in your document. They're all supposed to be unique within the document. We check for that. And also for scoped IDs, which are unique within the scope of their parent elements. So kind of a refinement on the ID. And again, those are about coherency and making sure that all of your documents as a set work together and you don't have any missing data. We also worked on some extensions for our own pipelines, mainly around animation and physics animation. We followed the Collada extension process, which has been documented, and there's a how-to at khronos.org, and there's a link here in the slide for you to follow. The first thing you'd want to do is not just start creating elements that describe your data or metadata for your problem or your solution, is to design the schema for it too, because then you're taking advantage of XML authoring tools, and you know that you're doing a proper job of merging your extensions within the whole scheme of Collada and any other extensions that might be attached. So that's what we did. We made a schema for the physics extensions. We imported the Collada schema to make the new total schema of Collada base plus the extension. And we wrote unit test cases, which the DAE validator runs as well, to make sure that our actual DAE documents, our actual content, is correct in the sense of the schema. So we did all that, and then we updated the Khronos website regarding the extension, so we advertised it. That's one step in the process, so other people can use it, so the whole community that uses Collada can have access to these extensions. And I'm talking with the Khronos webmaster now, where our extension schema is stable, so we're going to publish it at khronos.org, so it'll be available for download. It's actually part of the Open Collada distribution, so when you pull or clone Open Collada or you get a release of it, the DAE validator includes the local copies of the schema, just so that it doesn't have to be a network application. You don't want to have to go out to the network every time to get the schema to do a schema validation. So like I said, all these extensions are implemented in Open Collada, which we're supporting at Starbreeze. The animation one is actually for Collada Maya, the plugin from Open Collada that works with Maya. And we keep that up to date with the different years of Maya. So Maya 2015, 2017. We make sure that we are able to build with the newer underpinnings, not only Windows, but Autodesk application frameworks and stuff. So the purpose of this animation extension was to allow us to mark different frames of the animation so that we could associate them with side effects like audio triggers and logic triggers and behavior triggers in the game engine. It's a relatively simple extension. It basically is a bunch of timestamps, which are, as Collada is in seconds, they're all in real time. So they're not frame stamps, they're actual timestamps. And then IDs, which point to what the other resource is that you're interested in connecting to that piece of animation. So you load that data in your runtime, you build up your game object logic, and it works to provide those features in your game. So we made a little schema for that and added that to Collada as an extension. So it's a feature that is only available if you're using Collada Maya, though, of course, unless you implement it in your own tools, which you can do. The more elaborate extension we did was for NVIDIA's PhysX. So we use almost all of the features of the PhysX engine to do animation and physics and destruction and all that in our engine. And so we spent a good amount of time designing all of this properly, working with NVIDIA to get the latest SDKs for PhysX, understanding what the parameters do and how we should represent them, whether or not they had analogs to the base Collada physics features, so that we didn't overload or overlap them inappropriately. Then we designed the schema and implemented it in Open Collada, and as I said in the previous slide, we went through the process of publishing it and advertising it. The main features that we added were physics material extensions, so that all the PhysX metadata and control data that belongs in the material part of the physics Collada design. So Collada is, I don't want to go too deep into that, but basically there are objects, bodies, rigid constraints, shapes, and their properties are what we call a material. So a lot of those properties were added to physics material. Then rigid body is the thing that connects those to perhaps geometry in the scene, visual or non-visual geometry. Rigid constraints obviously are parameters that control how those bodies work, and then shapes pull it all together. So there's quite a bit of new data that's available in these PhysX extensions. I invite you to go look at the link and follow the information there. But we find that that's a lot more featureful than just using the base Collada physics, and it brings in all the new parameters from the last few evolutions of PhysX itself. When we did PhysX originally, back in 2004 or 5, we were working with PhysX team at that time and Bullet team, and the Collada physics is a kind of a superset or abstraction of both of those approaches. But over time, it's been stable, but the engines themselves have been adding in features. So it was basically a nice update for Collada physics. Kind of switching gears now. We also do continuous builds of Open Collada. So we have our CI system in the cloud, and it's Jenkins-based. And we, every time there's a merge into Open Collada from any of the contributors, Remy approves the merges as a pull request, if you know GitHub speak. And we go through a build process, a test process. So that's why the DA validator tool is valuable, because we actually use it as the automated unit tester as well. And when everything's good, then we do a release, and the release goes to GitHub as a release. And we push all the metadata for all the artifacts that were created. So there's actually standard reliable builds for multiple tools, multiple platforms that you can get from this process. If you don't want to build it yourself and you just want to get trusted binaries, they're provided through this process. Like I said, we do automated tests of Open Collada following the model of the conformance test suite, and it's something that you can get when you start to use Open Collada yourself. You can add to it, you can integrate it into your workflows. There's a lot of fine print here. I'm not going to quote it back to you, but it's something that you can run yourself, and you can add your own test cases to it. It follows the Microsoft unit test framework pattern, so it's fairly easy to integrate at the C++ or Python level. And if you want to add...
It's open source.
Yeah, it's all open source. Open Collada is open source from Khronos, of course. This is off of the Starbreeze Flare organization, but it's also open source. And so this is another tool you can use to add, quality assurance or quality control to your pipelines. So getting back to the whole binaries release process that I mentioned 2 slides ago. So when we do the actual release, we do post it back up to GitHub, and it is a GitHub release, and this one was done fairly recently. I think the slide's a week old or so, but we'll publish new releases when there's significant pull requests that have been merged in and passed all the tests. And they're usually driven by users who will create an issue. Like you can see, I think you can see, there's 39 issues that are being submitted, and those come from all over the world, from all kinds of different companies. And they get vetted, and they get worked on, and they submit their own pull requests for those things, and they get integrated. And when it's time to do a release, this is the outcome of the release. All of these are links to the specific binaries you might want for the plugin that you want for the version of software that you're using, whether it's Max 2011 or Maya 2017. And it's not only the plugins, but also the library itself. So if you're using the core library to empower your own tool or editor or your own import-exporter, you can get that too. And you don't have to get it all. You don't have to get something monolithic. You can grab just the pieces that you need or want. There's also, so there's Mac and Windows and Linux, Ubuntu builds of that. And of course, you can get the source code as a zip. You can also just clone the whole repository. One thing that Remy wants me to point out is we were maintaining a domain name, opencollada.flare.com, as a destination for the releases. So if you've been picking up Open Collada releases from that URL. It's retired, it's no more. We've changed some of our DNS records and we're not supporting that one anymore. And we also had a Dropbox destination, which was a bit unusual, but it was working for many years. We've turned that Dropbox off, but we've archived everything at the long link that you see at the bottom. So those will, all the old stuff if you need it, if you're in some kind of frozen state with your tool chain, you can always grab copies there. And I advise you to do so if you want. It'll be there for, you know, more or less permanently, but it's always good to have your own archive, right? This is a GitHub activity diagram for the Khronos Group's Open Collada repo. We populated it back in 2009, so it's been a few years now. It was, of course, very active back then, and it's gone through some relatively quiet periods through the years as it's been maintained and updated. In the last couple of years, we've seen an uptick in the average activity, and people are finding Collada more useful in the modern era, and so we're seeing a lot of activity increase there. And as the slide points out, we've done 75 merges in just the last calendar year of significant changes and improvements to the tool, and we're encouraging people to focus their attention on Open Collada as the sort of reference implementation, so that it can get better and focus the industry instead of diluting the industry. Oh, I got to the end, or thank you part? I thought you were going to finish off. All right, well, thanks everyone. I guess we're open to questions now.
Just a few.
Okay, any questions?
Hello, what's your motivation for using Collada in Starbreeze?
I think that's a good question for Remy. He preceded my arrival at Starbreeze, and he was using it already in the internal engine project that we were doing. The main reason, I would say, is because we were using multiple authoring tools. So the usual, let me go back a bit. The usual picture that Collada enables is this one on the left. And so we are a case where we're using Max, we're using Maya, we're using Motion Builder. And we have multiple game engines internally. We use Unity on some projects, we use Unreal on others, and we have internal proprietary engines we use. And so the way to get data through all these tool chains is obviously Collada. That's the use case it's designed for. We're sort of biased towards using it because we think it's a good idea.
The other practical reason is that as the project progresses, you suddenly need, I need that information, I need that data from this tool and so forth. And it's pretty much ad hoc developed in a lot of game companies where you add this text file there and this JSON thing there, and then you end up with a bunch of files, don't even know if you need them and what version they were and so forth. So it was a lot more cleaner to say, well, we're going to create extensions, get schemas for them, make sure that we have a specification in one language to talk about the things we need, and that actually improved a lot. Not the developers are like, it's it's a lot more work to define it correctly, but long term, it's actually way more productive. So,
what has been the issues with using Collada? Has there been any for you?
Well, it's a bit more work. So game developers don't necessarily like to do the clean work. They like to go, do the hack. So the issue is mostly reserving enough resources to do it cleanly. But we can do that after the fact. And but even though it's like, why should we spend time cleaning? We just need to release our game, right? So that's the main issue. Is the little bit of a conflict between releasing a game now when we don't care about keeping the data, and well, we should do it cleanly so the company can grow and learn. So I guess that's the usual. It's the same with every other clean way of doing things, I guess, versus hacking it to make it a quick release.
I have a part of an answer. On top of that, like Remy mentioned, just the release and post-release sort of feeling. But games aren't just released once anymore. There's downloadable content. There's constant updates to games, especially when you're on something like Steam or a mobile game environment. And so your data actually isn't done when there's no gold master kind of scenario anymore. And so you want your data to be there and viable potentially a couple of years later when you decide to port that game to a different platform or a different console. You want to be able to still get to that data without a lot of build-up work. And if your data is stuck in Maya 2010 and doesn't quite import anymore into the current tools, that's a problem that you can avoid because Collada content will still import.
Most of the time, it's not stuck actually in the tool. It's stuck in the engine itself, because the engine, engine actually are not super well documented, and they evolve a lot. So, so this is where I get stuck most of the time. It's like you do this quick, interface to the engine, this hack thing to get the data you need, and then the engine evolves. Right? You have a new. Actually, we may even change from one engine to another engine completely, and still need to keep the IP, right? And at that point, what you have to do is rewrite completely from scratch. And so that's really where Collada has been super useful to save money, basically.
So what has been the benefits of using Collada over like FBX or alternatives?
Oh, but FBX is limited in what it can export. I mean, obviously there's no physics export. There's no link with. There's no. But I mean, if you want to do everything in one engine, and you can import just your geometry with FBX, and you do everything in the engine using the engine editor, and you save in that engine, and you put all your eggs in that engine basket, and you're stuck there, it's fine. If you only have the option to use different tools, change engines in your future, you do the additional investment, and you use Collada. So FBX is an easy path, fast path that strategically is not the best unless you really want to be stuck in and you're happy with it. And Collada is the more thoughtful, strategic, longer-term investment.
Thank you.
All right, thanks, guys. It's 11 o'clock, so it's time for switching over to the next BOF. Thanks, Mark and Remy.
Thank you.
All right, so GLTF folks, let's get set up. We'll start the BOF in just a couple of moments. Hey. Good to see you again.